Guys, good morning. Okay, I think we have listened to some of the portions of from the chapter Laws of Motion in the live class itself, and I hope you guys have listened to the topic of conservation of momentum, free body diagram, tension, etc. So I hope you understood those concepts, right? So today we'll be starting with the portion from second law of motion, which I have started a little bit, and after that only we talked about momentum, etc. Right? So here we are going to go to or dealing with the second law of motion in detail. Okay, something I have to inform you guys is I'm taking all the topics in the CBSE point of view, and entire thing is there in the textbook but not in the order. That is, see, free body diagram etc. in your textbook comes in the last, but I have taken it in the first section itself because I believe that for the first learning theory and then doing problems related to it is not effective. It is better that you bring the theory part and the problems side by side. Okay, so let's move on to the second law of motion, which you have learned as F is equal to ma in your lower class, and commonly you have learned as F is equal to ma. But actually the second law of motion is not this one, right? What does this second law state? That rate of change in momentum is equal to or is equal to the amount of force applied, or actually this delta p by delta t is equal to force. This is the actual what statement or the implication of the statement of second law of motion. That is if there is a mass m like this, and a force F is applied over it. Initially, let's say it is moving with the velocity u, and due to the application of force, this mass has final velocity v, right? And suppose this is all is happening during the duration of t seconds. So what is the initial momentum in the first condition here? It is equal to m1u. What is final momentum? It is m into v, right? Let's take it as m itself. So mass is not changing, right? That's right, mu. The p2 is mv. So what is change in momentum? P2 minus P1, that is m into v minus u, right? So delta p by delta t will be change in time interval is t. So it is this form, and we just learned that this is equal to force. So force is equal to m into v minus u by t, and this v minus u by t can be written as a, hence it is ma. This is how you have learned in your 10th class the derivation, right? That is, see guys, this equation, that is force is equal to ma, holds only when the mass is constant, which is universally around 90 percentage, or in the all world condition, if you say at least 80 to 85 percentage conditions, mass is constant. But there are various conditions the mass is not constant, so we have to correspondingly understand that also, right? Now the best example is, let's say, our rocket. This is the example which has been given in your text, but I will give you another example also, right? When the rocket is fired, a lot of exhaust gas comes out. How does the exhaust gas come out? It is by due to the burning of fuel. That is, initial mass of the rocket was due to the mass of the rocket plus the mass of the fuel, right? Now as the rocket goes up, the mass of the fuel goes on reducing, right? That is, I can say this section goes on reducing, or initially the mass was high, or so let's say if it was a 2000 kilogram, then its mass goes on reducing due to the reduction in fuel, right? So in this condition, I can never use the equation F is equal to ma, because mass is not constant. That means I have to here use the equation F is equal to delta p by delta t. That is, you have to introduce change in momentum. So that is, what was the initial momentum when the fuel was there, and what was the momentum after fuel is emitted, right? Similarly, there is another condition. Let's say you have learned about Einstein's theory of relativity, right? So see, I hope you know that if there is a mass m, right, if it is moving with any velocity, right, let's say v, right, its mass goes on increasing. That is, if a body is moving with a speed, its mass goes on increasing, right? And if this velocity has approached the velocity of light, then the mass will be very very high. What do the else say about the current mass, which is the object which is in motion is equal to resting mass divided by 1 minus v squared by c squared. That is, if the initial mass, let's say, is anything, right, which was at rest, okay, after it starts to motion, it becomes velocity m, and the new motion or mass depends upon the initial mass in this way. Say, I told you when the object is moving with the velocity, it regains mass, right? How can I prove it? Is, suppose the object is moving with the velocity not v, initially it was velocity v, now it velocity changes to c by 2, not c, okay. So m is equal to m naught initial rest mass 1 minus v squared, I can write it as c squared by 4, right, divided by c squared, right. Then I can write, then c squared cancels out, and so I can write m naught divided by root of 1 minus 1 by 4, or m naught divided by root 3 by 4, or it is equal to 2 m naught by root 3. This is the current mass of the object which is moving with the velocity c by 2. So initially its mass was m naught, right? Clear? Now its velocity has increased, right? Right. So I can just say that when an object is moving, its mass can change, right? So I can never use force is equal to ma in this condition, because here the mass is changing. So there is a change in mass as well as velocity. So how can I have this confusion removed by using a constant relation? That's why it is best to use the differential form of Newton's second law, right? That is, we know F is equal to delta P by delta T. Now in place of delta, write it as dP by dt. That is small dp, or small momentum change by small time change, right? So I can write it as d by dt. We have learned P is equal to mv, right? Okay, so now product rule applied. That is, when differentiation of the product is done, first take one factor m, then differentiate the other guy, plus then take the other guy phi, then differentiate the other one, right? Let us listen to me. If the d by dx of ma, then it is m, which is constant, take it as outside. First m is taken as constant, so it becomes m into dA by dx, plus then take a as constant a, then there is dm by dx. This is how the differentiation, or this is known as product rule of differentiation. If you don't know, better study it, right? Now this is actually the best equation for the second law of Newton's second law, right? Suppose, see, the condition, earlier condition which you have learned from the lower class, when mass is constant, right? When mass is constant, that means dm by, there is no change in mass, so I can write dm by dt is 0, so this part becomes 0. So I can write m dv by dt. That is rate and change of velocity, I know is acceleration, then comes up F is equal to ma, right? So you can produce any equation from this basic equation, so better you learn that equation. Clear? Right. Now I hope we'll go to the some of the problem. It's not exactly problem, but it is based on this entire thing which I am going to take is based on our Newton's second law of motion. And again I am repeating, it comes in your textbook in the last section only, okay? And I hope you have understood what a free body diagram is. Free body diagram means a pictorial representation of an object, right? And what and all force it is being acted upon can be pictorially represented. That representation is known as free body diagram, right? I am repeating again. Suppose again, this is our mass, right? Right. So what and all forces can be acted? Now I taught you guys, yet I am repeating it again. There will be weight, which is mg below, and I told you if this is on a surface or a ground, the ground will equal and opposite reaction. This is actually opposite. Our third rule is also acting, but I'm just evicting you. And let's say that is a normal reaction of Earth, which is n, right? Now let's say a force is applied like this. It is pulled, right? So when the mass is moving, obviously it will be experiencing an acceleration in this direction, right? Clear. So what and all can be written for this free body diagram? N, that is, let's say, vertical conditions. Vertically, how many forces are there? N. And then it's a downward. So I will write N is equal to mg because both are equal, right? And there is no other forces in vertical direction. So I can write N is equal to mg. Now in horizontal, how can I write? Right? It is very easy. F. And this acceleration is acting on this mass. So F is equal to ma. Right? Force has to be equated, right? Due to this acceleration, this mass is moving. So I will write F is equal to ma. Clear? I will do a lot of problems. Sorry guys. Now the next question. Let's say this is a mass, right? So let's say two forces are acting. F1, right? And there is an acceleration like this because, okay, let me tell you there's a question, sir. Suppose what happens when F1 and F2 are equal? These two forces will be equal, means the object will not move. At that condition, I say the object is at equilibrium. Remember, right? When there is no motion, then the object is said to be at equilibrium. Right? Right? Clear? Now, suppose I say F2 is greater than F1. Remember, that is, this force is greater than this one. So in which direction the object will be moving? Obviously in this direction, right? Suppose this is 30 Newton, this is 10 Newton. So how much or where will be the object moving? Obviously in this direction, right? Okay, keep that in mind. Right. So that means the acceleration is in which direction? The acceleration is in this direction. Okay, good to go. Now, what any other force is acting? Yes, the object will be exerting a weight downwards to the ground, and the ground will be applying a perpendicular normal reaction upward. Good to go, right? Now, what and all can be written here? Again, make vertical forces, right? The condition for vertical forces, only two forces are there and they are equal and opposite. N is equal to mg. Right, how much weight you are applying, that much weight or reaction will be only provided by the earth to the body. So N is equal to mg. Right, now when now in horizontal condition, what and all are there? Now this is something which you have to keep this in mind always. This is a rule, not a rule which I am making. Actually this is a rule I am making so that it is very easy for you guys to take which is positive and which is negative. Always take the direction of acceleration as positive. So all the forces which is in the direction of acceleration will be positive. So I can see F2 is in positive direction. So I will write plus F2. Right. F1 is opposite to the acceleration direction. Hence it is minus F1. And that is equal to ma. That much force is acting on it. Right. So F net will be written this way. Right. So what will be the net acceleration of this body? A is equal to F2 minus F1 by m. Right? Clear? Right. Now let's change the question. This is the mass. Right. Let's say the force is acting on it in this direction so that it is making an angle theta with the horizontal. Right. And you are asked what a given expression for A. That is acceleration. How would you do? Make force into two components, F cos theta, and this is the vertical component, F sin theta. Right. Similarly, what and all other forces will be there? Weight downward, that is mg, and normal reaction upwards. Clear? Right. So how and all I can write this one? I can write vertical forces. First I will write vertical forces. That is n and f sin theta are upward and mg downward, means I can write n plus f sin theta will be equal to mg. Right, that is the object will be exerting that much power downwards depending upon the force as well as depending upon the reaction it is getting. Right, so vertically this is depicted from the diagram itself, right? N plus, because there is no vertical motion, guys. So vertically the object is at equilibrium. The horizontal motion will be there. That is, the horizontal motion is due to f cos theta. F sin theta is not exerting any movement. That is, you are told object is in equilibrium, or not told, it is known to you that the object is not moving. Obvious, it is not going to move up. So there is no vertical movement. Right? Clear? So I can say by this equation, there can be a vertical movement. That and all will go for the next section. Right? So similarly, let's go for horizontal condition. Now, horizontal condition, there is only one, that is f cos theta force. So since there is no other horizontal force, I can write f cos theta is equal to ma. Right? Or I can write acceleration is equal to f cos theta by m. This and all are not equation, guys. These are type of problems which I am going to do or trying to do so that you understand the basics of it. Okay. Now, similarly, now let's say this is 5 kilogram mass. It is acted upon by 20 Newton of force, which is at an angle, say 37 degree. Right. Now this is another force 10 Newton acting into, and it is at an angle 53 degree. Right? And you are asked what is the acceleration, net acceleration. Right? So again, how would you do it? Again, I can make this force. This is 20 cos 37. This is 20 sin 37. Right? Similarly, 53, sorry, not 53, 10, no? 10 sin 53 degree, 10 cos 53 degree. Right? I divided them into components. Then there is mg downwards, and then there is n upwards. Right? Just like the previous cases, write the vertical forces. What are the vertical forces? Look into the diagram, guys. Right, first we will write all the verticals which are in downward direction. Right, which and all are in the downward direction? There are two, which is 10 sin 53 degree. Right, and there is another one which is mg. Right, and in place of m I can write 5. Right, so I will write it as mg. mg plus 10 sin 53 degree is equal to the forces vertically upwards, which is n plus 20, right? 20 sin 37 degree is also upwards. That is equal to n plus 20 sin how much? 37 degree. Right? Now I can write mg as what? Mass, right? So I will write it as 5 g is 10 plus 10, 53 degree. Sin 53 degree, if you don't know, it is 4 by 5 is equal to n plus 20 sin 37 degree is 3 by 5. Okay, right? Now it's equal to 50 plus 10 by 2, 2 to 8 is equal to n plus 4 plus 3 is 4 to 3 is 12. Right, you will get n as how much? 46 Newton from this one. Right, now I can use, suppose let's say you are told the object is moving in the forward direction. Suppose the acceleration is given in forward direction. Right, that means I can write this direction as positive, that is 20 cos 37 is positive. That is our horizontal forces. So 20 cos 37 degree plus 10 sin, so not sin, cos 53 degree is equal to ma, because both are in the direction of acceleration. See? Right? So obviously the acceleration will be in this direction itself, even though it is not given. Right? So 20. Now what is cos 37 degree? It is 4 by 5 plus 10. What is cos 53 degree? That is 4 by 5 is equal to m a. Now what is m? M is 5 now. So 5a. Right? Okay, I wrote both of them 4. Cos 53 degree is 3 by 5. Sorry guys. I told 3 I believe, but I wrote 4. So it is 3 by 5. Okay. Now this is what 25 cancels, so becomes 4 into 4 plus 2 into 3 is 6. 5a. 16 plus 6 is 22. 22 by 5 is acceleration, or a is equal to 4.4 meter per second squared. See, this is how you do a problem. Not a big deal if you make the big deal of this stuff. Okay. Now similarly, this is a block M1. Now there is another block M2. Right. Now I am applying a force here like this. Right. Now let's say if I apply a force like this, right, then both the blocks will be having an acceleration because they are in contact A. That is, both of the block will be having the acceleration A itself. That is, if I apply force on M1, then M1 and M2 will be moving with the same velocity and acceleration. Keep that in mind. Right. If I apply force here also, both will be having the same value of acceleration. Clear? Now whenever you are doing a problem and there is a two contact bodies, always draw the bodies in different way and that is separately, and find their or write their equations. So free body diagram for M1. Okay, so M1 is experiencing a force directly. There is an weight M1g below. Obviously due to that weight, ground will be giving a normal reaction. Now this acceleration in this direction. Now tell me another thing, if there is any other force acting on it. Yes, there is a force. See, M1 and M2 are in contact. So when you push the first block by F, there will be a normal reaction, right? There will be a normal reaction, right? Not this way. That is, M1 is applying a force on M2. Then M2 will be giving a normal reaction in this direction. Let's say N. Let's say that let's say that is N. Or I have written N now. Let's say that is N dash. So similarly, M1, right? If M2 is applying a reaction to M1, then M2 will be experiencing a reaction N dash itself from M1. That is, there is a to and fro. That is a third law, right? Equal and opposite reactions. So M1 will be exerting a normal reaction N dash on M2. Similarly, M2 will be exerting a normal reaction N dash. So M1 is experiencing a normal reaction N dash from M2. Okay. Now I told you all the directions. Vertical I need not write. N is equal to M1g. Simple. Now there is no vertical movement. So horizontal movement acceleration is there. I told you A direction is positive. So F is positive. And then there is N dash is equal to NA. Right? Clear? Now, next we are going to consider the second block, which is a elongated one. Let's say it is M2. And M2 is experiencing a weight downwards, a normal reaction, let's say N. Let's say it is N2. It's okay. And so N2 will be equal to M2G. Right? Now M2 will be exerting or experiencing a normal reaction N dash from M1, right? And we told there is an acceleration. Then acceleration this way. Then you will ask me, what is the force? Force is acting on M1 and M2. No, force is acting only on M1. It is not acting on M2. M2 is moving in the forward direction due to the pushing from M1, or I can say due to the normal reaction, which is this one. Okay, right? So in this equation, or here I can write N dash is equal to M2A. Right? Clear? So in this is the equation for vertical equation for what? First block, and this is the second equation for the horizontal equation for the first block. Clear? Right? Now let's say you are asked what would be the net one. How can I find? Let's put this one as first equation, right? And let's put this one as second equation, and let's add. So F minus n dash plus n dash is equal to, this is m1, m1a plus m2a. So n dash cancels out. So I can write F is equal to m1 plus m2, there is a common a. And if you are asked acceleration straight away, acceleration is equal to F divided by m1 plus m2. Now, so I could have just given you the equation just by heart this equation and substitute, but I don't think that helps out, right? Because you require the entire theory of doing how a function or how it happens. That's why this derivation has been done to you, right? That is, suppose I give an example question like this. There is a 2 kilogram block, then there is a 3 kilogram block, and there is a 4 kilogram block close to each other, and I am applying a force of 80 Newton over it, right? Now your first question is, what is the acceleration of the system? You have to take this as a system because each and everyone will be experiencing the same acceleration. So I can just write acceleration is equal to net force, which is 18 Newton acting on the entire body as a force, divided by net mass, that is 2 plus 3 plus 4, that is 7, sorry 5 plus 4, that is 9, that is you will get acceleration as 2 meter per second square. Now another question, let's say what is the normal reaction between 3 and 4? So suppose I just take 3 and 4. Let's say this is a normal reaction which is given by 3 to 4, and 4 is applying the same amount of normal reaction in this direction, right? So let's say I can just consider acceleration for this block also. So just write or draw the 4 kilogram weights free body diagram. 4 kilogram will be having 4g, or I can say 40 Newton in the downward direction, right? Then the equivalent there will be n. So I need not look into that. Now there is a a normal reaction, let's say n2 in this direction, right? And the body is moving in this acceleration. Okay, so n2 can be written as 4 into a, right? And I just found for a's value as 2 meter per second square. So I can just write n2 is equal to 8 Newton. That is the normal reaction between the surfaces of 3 and 4, or the force applied by 3 kilogram on 4 kilogram and 4 kilogram on 3 kilogram. Okay, right? Now similarly, see guys, if you feel that you are having difficulty in understanding, pause the video and try to listen to it again and again. Okay, now suppose you are asked, you're given a scenario like this. There is a block A here and another block B. Let's make the B block smaller, right? This is block B, and this is having mass m2 and this is mass m1, right? And you are giving push or force to m1, right? Now tell me what will be the acceleration of A and what will be the acceleration of B. Just take under, let's say all the surfaces are smooth, that is here it is smooth, and between these two guys also is smooth. Before thinking in a physics way, think it as a common sense. That is, if you just give a push, that is, suppose you are having very the floor is glazed, or you are put oil over it, and you have kept over that a glass slab, and over the gas slab you have again poured a lot of oil, and on that and another glass slab has been kept, and you push the glass slab in the lower position. What happens to the upper position? Common sense, you will feel this block, that is the down block, will be moving in this direction, and you will feel the above is moving towards you, and later on it will be falling, right? This is what happens. That means I can say the block B has zero acceleration, doesn't have an acceleration, because only m1 moves, right? So the acceleration will be only for m1, means acceleration will be F by m1 in this case. If both or all the surfaces are smooth, okay, not the case where there is a friction. Clear? Right? Now similarly, let's say I told you as a theory, let's say if it is true or not. Okay, let's say I have taken the first block m1 and we have applied a force F over it. There is a weight m1g downwards and there is a normal reaction upwards, right? Clear? And see, there was a small block over here. No, that block would have given an additional normal reaction in downward direction. And I'm telling you, due to this force, obviously this block would have moved in a what? This direction. Now, what and all are the vertical forces which are happening in this block? There is in vertical condition the equilibrium is happening, right? There is no vertical motion. That means I can write m1g plus n dash, that is both in the downward direction, is equal to n. Right, now what can I do? How write about horizontal condition? F is in positive direction, right? So F is equal to m1a, or Ia is equal to F by m1, right? So you would ask me, why can't we draw the B block? We can draw the B block also, m2, right? M2, obviously it will be M2G, and there will be a normal reaction, and there is an additional N dash reaction which is exerted by first block on this one, right? So there is no horizontal forces, right? There is only vertical forces, hence the acceleration in the x direction is 0, and y direction is also 0 because there is no movement in vertical direction, right? Clear? Now suppose, that means if in this above section there was an observer inside this block, right? For him, what he will feel, that this block is moving in this direction, right? And how much acceleration? You just found this, let's say I am telling you, if this acceleration of this one, that is the first block, this one, let's say it is 2 meter per second square. I'm just telling you an example. That means the person inside the block M1 will feel M2 is moving the 2 meter per second square in opposite direction, that is minus 2 meter per second square. Clear? That is acceleration of B with respect to A is equal to minus 2 meter per second square. Clear? Now similarly, I am just adding the things because it is very easy to make you understand like this. Let's say this is block is of 4 meter. It's large now. 4 meter block. That means how much distance the B has to travel to fall? It has to travel how much? 4 meter, right? So that it falls. So the distance it has to cover is 4 meters. So how much is the time by which the block B falls? How can you calculate? Again, S is equal to ut plus half at squared, right? Initially the block B was at rest, right? It was not in motion. So I can term this one as 0, that is equal to half. Acceleration is relative acceleration, right? So minus 2, and there is t square, and what is the distance? 4 meter. So you can find t as plus or minus 2. You will just write it as 2 seconds because time can never be negative, right? Clear? That is, the block B will fall after 2 seconds. Okay, simple, right? Next type of questions which comes up is question regarding the tension. Okay, suppose there is a mass m1 like this, right, and connected to that there is another mass m2, right, and I am pulling this mass m2 by the force F, right. So definitely you know the entire system will be moving with the acceleration because they are connected. So this mass m1 will be also moving with an acceleration a, right. You are asked what is the expression of A, right? Clear? Right. So if you are applying force in this way, so both mass m1 and m2 will be having the same displacement, as well as they will be having same velocity, and since velocity change is same, their acceleration is also same. Okay, simple, right? Okay, now moving on, right? How can we do this one? See, there is usually, not usually, around 100%, or I can say 99% of the CBSE board question or NEET question, the string is always considered massless. That is, the string's mass is never considered. Okay, so always it is mentioned. So let's say similarly this string is also massless. Okay, now let's consider the first mass, right? We have to draw the free body diagram, that is, we have to find all the forces applied on it, right? So there will be a weight of m1 which is m1g downwards, a normal reaction by the ground, right? Now we know this is a string attached, right? So a tension will be always, tension is drawn away from the body, right? So there will be a tension like this, right? And we just draw that acceleration of m1 is in this direction, right? So what and all can be written regarding the vertical forces? N is equal to m1g. Regarding horizontal force, I can write T is equal to ma, right? Now let's move on to the next mass, that is second mass, that is m2. m2 here, this is m2 mass, okay, and there is just like previous one, n reaction upwards, m2g downwards, right? And the string here is connected in this one, right? So the outward direction of tension like this, right? Tension is always drawn away from the body in the case of a free body diagram, clear? And there is a force applied like this, right? So how would I write the equation? For vertical it is n is equal to m2g, and horizontal it is equal, and there is an acceleration also, right, in this direction, and acceleration direction is taken as positive, then f is positive, t is negative, is equal to ma, right? Clear? Or here I have to write m2a, right? Now in place of t, I am going to write this m1a from previous section, so it becomes f minus m1a is equal to m2a, or I can write f is equal to, a can be taken as common, so a into m1 plus m2, or I can write acceleration is equal to f divided by m1 plus m2. It is just like the previous case. Remember, we had two blocks were joined that also had the same acceleration equation, that is net force divided by net mass, right? I'm sorry for the dog barking, can't do anything about it, okay? Right, now let's do a small problem with it itself. Suppose there is an 8 kilogram here, right, and it is connected to another weight, let's say 7 kilogram, and a force is applied of 30 Newton. Let's say it is making an angle 60 degree with the horizontal, right? And since the pulling is happening in this direction, acceleration will be in this direction. You are asked what is the value of acceleration. So how would you do it? It's simple maths. So first I have told you, whenever you are getting a figure like this, or you are getting a type of question like this, so always take each mass separately, right? And see, the string is there, so tension will be there, weight 8g, downwards, upwards normal reaction, that is only forces which is happening regarding 8 kilogram. So vertical force, and there is an acceleration, right, in this direction. So vertical force I can write n is equal to 8g, right? And horizontal direction I can write t, right, is in the same direction of acceleration, so t is equal to ma, right? Similarly we can do the block for the block 2 also. Let's say, okay, I have to change the position of it because it has a linear or angular free force 30 Newton, right? Now what and all are the downward force? 7g, because if the mass is 7, upward force is n, there is an acceleration in this direction, right? And since 30 Newton is acting in 60 degree angle with horizontal, this is 30 cos 60 and this is 30 sin 60. That is, I have resolved this force or this vector into two components, right? And there is another section, right, tension away from the body, right? Now write the components of this section for the forces which are happening in let's say vertical. It is n plus f, or what is f here? That is 30 sin 60 is equal to 70, 7 into g, right? Then here also I can write it as 80, and here I can write 8a, right? Now then similarly, then there is an f cos 60, right? So I will write it as 30 cos 60 minus t is equal to 7a, right? Right, now here I have t is equal to 8a. I can substitute here, so I will get 30 cos 60 minus 8a is equal to 7a, or 30 cos 60 degree is equal to 15a. Right. Now what is cos 60? 1 by 2. So here 30 by 2 will be 15 is equal to 15a, or I will get acceleration as 1 meter per second square. This is the acceleration of this entire collection or system. And if you are asked what is the tension, you can just write T is equal to 8a, right? So 8 into 1, that is 8 Newton. Right? Clear? Now, similarly, there is another section which is pulley system. Right? This and all comes in the free body diagram section itself, right? But it is distorted in our textbook, and this pulley system questions are asked, but the theory is not provided in your textbook point of view. Okay, so this and all are coming, actually this and all are connection motions. Okay, that is bodies are connected, right? So consider two bodies, right? Suppose this is a pulley. I hope you know what is pulley. The thing, see, you in the old age or nowadays also, you used to get water from well using this one. Ouch. Aha. Fish. How many times I'm going to draw, I don't know. Right? So okay. Now let's say this is mass m2, right? And let's say this is mass m1. Okay. Let's push this one. Right. Now, what and all, and we are given a condition that m1 is greater than m2. Right? So tell me, if m1 is greater than m2, then obviously this will come down, right? So in which direction the acceleration will be? In this direction. Common sense, right? Clear? That means if this body is accelerated downward, then this body will be accelerated upwards in the same value, because they are connected body, right? Now there will be tension away from m2. Let's say the same string is here, so here the tension will be away from the body in like this. Clear? Now there is a weight m2g here. Similarly, there is a weight m1g here. Right? Clear? Right. Now we'll write the equations for each masses. Right. Since there is no horizontal equation to be done, because there is no horizontal motion or horizontal force is not there, there is only vertical, right? So how can I write for the first mass? I can write m1g, see A direction, which is m1g, positive, minus T, opposite direction as that of A, is equal to m1A. I will bring it here, m1A. Right, let's make this as the first equation. Right, now for mass 2, what can I write? See, T and A are in the same direction. So T is positive, then m2g is negative. Right, is equal to m2A. That is your second equation. Right, clear? Now add this first and second equation. Right, you will get m1g minus m2g. Why? T cancels off, is equal to A into m1 plus m2. Right? Or I can just write A is equal to m1 minus m2 whole g divided by m1 plus m2. Right? This is the expression for acceleration of a connected bodies if they are on a pulley. Simple, right? Clear? Now similarly, I can say, I can use this equation for finding tension also. You can write here. How can I find tension? See, tension, see, we go for the previous one. Let's say in the second equation, can I write tension is equal to m2a plus m2g, right? Or can write it as T is equal to m2g plus m2a, right? Clear? Or I can write m2g is equal to, right, plus m2. You have found the expression for A right there, m1 minus m2g divided by m1 plus m2, right? Clear? Now we will expand these things, m2g plus m2 m1 minus m2 squared divided by m1 plus m2. This and all are multiplied by g, right? Or I can write it as m1 plus m2 into m2g plus m2 m1g minus m2 squared g, right? Now here, and there is a denominator m1 plus m2, right? This and all are expansion, guys. You guys can do it by yourself actually. So then there is m1 m2g plus m2 squared g plus m2 m1g minus m2 squared g divided by m1 plus m2. Now this term and this term cancels out. So you will get two common factors, that is 2m1 m2g whole divided by m1 plus m2. This is the expression for tension. Clear?